Take a look at number 18 in section 5.4. We're going to evaluate the integral using FTC1, Fundamental Theorem of Calculus, Part 1. And here is our definite integral to evaluate. A couple things on this one, a little tricky. First of all, the way I would, a couple ways of thinking about it, but I want to look at this expression that we're integrating the function e to the 1 minus 4t. I've written it here. Notice it can be written this way as e, or it is e to the first power times e to the negative 4t, right? When I'm multiplying like bases, right, what do we do with these exponents? We add them. What is 1 plus a negative 4t? Well, it's literally 1 minus 4t, right? So you can write it this way, but e to the first power is just e. And so this is just a constant multiple. It's like e is a number. It's like 3e to the negative 4t or 5e to the negative 4t. It's just e to the negative 4t. So I'm going to use that fact. I'm also going to use this fact, which we developed in class, actually. The antiderivative of e to the kt is not e to the kt, right? Where k is some non-zero constant. If k is a constant, notice the antiderivative is 1 over k e to the kt. Why is that? Well, if you take the derivative of e to the kt by the chain rule, right, you've got inner function kt, outer function e to the u. The derivative is what? Outer function derivative is just e to the u, e to the kt, times the derivative of the inner function. Derivative of kt is k. You get k e to the kt, right? So if I take the derivative of this, I get k e to the kt. I want e to the kt. So how did I need to balance that out, so to speak? Well, I multiply by 1 over k, right? So now the derivative of e to the kt is k e to the kt times 1 over k is just e to the kt. So that's important in doing this. And we'll talk more about this as we get into the substitution method or technique of integrating, which basically helps us in one way undo the chain rule. Okay, so together, I just want to look at the indefinite integral. Notice I don't have the limits of integration. What's the? I just want to find the antiderivative of this thing, and then we'll use the fundamental theorem of calculus, part 1. So first of all, I rewrite this in this form here, and this e is a constant multiple. I can pull it out, leaving e to the negative 4t. Well, what's the antiderivative of e to the negative 4t? Well, I'm now going to use this where k is negative 4. It's going to be 1 divided by negative 4, or negative 1/4 e to the k negative 4t, right? There's the antiderivative. Now I can multiply back by e. Remember, e times e to the negative 4t is e to the 1 plus a negative 4t or 1 minus 4t. So I just put it back in that form. So this is the antiderivative, right? Of course, I put the plus c here for the indefinite integral. But when I go back to the definite integral, right, using the fundamental theorem of calculus part 1, I'm just going to use the antiderivative where the constant of integration is 0. Right? I get this as my antiderivative. I'm going to evaluate that the upper limit of 2 and the lower limit of 0. Okay. When I plug in 2, now this negative 1/4, I'm just going to factor that out right here. So now I'm going to plug in 2. What do I get? 1 minus 4 times 2 is 8. 1 minus 8, that's negative 7. I get e to the negative 7. So this right here is the evaluation when t is equal to 2. And then I'm going to plug in 0. What do I get when t is 0? I get 1 minus 4 times 0. That's 1. I get e to the first power. So that's not 0, that's e. So that's when t is 0. So this would be a fine answer right here. I just factored out the negative 1/4 here. You could distribute it back through. In fact, I could rewrite this in a little bit of a different form. If I multiply through by negative 1, if I distributed the negative 1 through here, right, I'd have negative e to the negative 7 plus e, right? Of course, this is positive 1/4 now. And then I can rewrite this negative e to the negative 7 plus e as e minus e to the negative 7. Okay, so just showing you the different forms, this would be fine. I think achieve actually for me was showing this is the answer. Hopefully we'll accept this as well. Any of these would be acceptable. As you're doing problems and you're checking with an answer, say in the back of the book or someone showing it you the answer, you've got to be able to have think about simplification or rewriting the expression because if you have this and you look back and you see this is the answer, you've got to see that, oh, it's actually the same thing, that you've got the correct result. You just need to rewrite it in a different form. Okay, but any of these three would be sufficient answer. And they often want the exact answer. Now you can use your calculator's integrator, function integrator to approximate the integral, but it's not going to obviously give you this. You can use your calculator to approximate this and check with that. Okay, I hope this is helpful.